Okay, now here we are at the general form of conic sections. Now, as you can see, the second variable here is bxy. Now, in most of the equations before that are not rotated, b is equal to 0, so therefore it cancels out the xy. But when you are working with rotated conics, b is not equal to 0, and therefore that signifies a certain degree of rotation on your conic section. And that brings us to our first topic of the day, which is writing rotation equations. Now here we are given x squared minus 5x plus y squared equals 3, and we are also given the rotation of theta, which is pi over 3. Now in order to write this equation with respect to the rotation of pi over 3, we have to substitute x with x prime cosine theta, and we have to substitute y with negative x prime sine theta plus y prime cosine theta. Now as you can see here, I've already substituted that in the equation. Next, of course, you use your unit circle to find out cosine pi over 3 and sine pi over 3. Cosine pi over 3 is 1/2, and sine pi over 3 is root 3 over 2. Then, of course, you use the FOIL method accordingly to get this equation here. And once you've done that, all you have to do is simply add the like terms, and you end up with x prime squared plus y prime squared minus 5/2 x prime minus 5 root 3 over 2 y prime minus 3 equals 0, which can be then, made more understandable with 2x prime squared plus 2y prime squared minus 5x prime minus 5 root 3 y prime minus 6 equals 0. And that is your answer right there. Now the other, half of basically the rotated conics is finding out the angle of rotation. Finding out the conic that it is. So that is what we're going to do here. So in order to identify the conic section that is rotated, you have to use the discriminant in the quadratic equation. And if you don't already know that, the discriminant is b squared minus 4ac equals there. So here you go. B squared minus 4ac is less than 0, and a is equal to c. The equation is a circle. If b squared minus 4ac is less than 0 and a is not equal to c, the equation is an ellipse. If b squared minus 4ac is greater than 0, it is a hyperbola, and if b squared minus 4ac equals 0, the equation is a parabola. Now, of course, your b is the term that is in front of the xy, the a is the term in front of the x squared, and the c is the term that is in front of the y squared. So all of that you have to get from your general form. Next, to find the angle of rotation, you have these two following conditions. If a is equal to c in your general equation, then theta equals pi over 4. Pi over 4 is your angle of rotation. If a is not equal to c, then you use the equation tangent of 2 theta equals b over a minus c. And if you solve that for theta, you will get your angle of rotation. Okay, and that brings us to our final problem that uses those two concepts. So here's the equation, 8x squared plus 5xy minus 4y squared equals -2. And we are asked to identify the graph, identify the angle of rotation, and then graph it on our graphing calculator. So let's get started. First, of course, we have to put this in general form in order to figure out what a, b, c, d, e, f, etc. are. So here it is. 8x squared plus 5xy minus 4y squared plus 2 equals 0. And from that, you know that a equals 8, b equals 5, and c equals -4. Now, using that information, we can use our discriminant here, which is 5 squared minus 4 times 8 times -4, and that equals 153. Now, 153 is greater than 0, which therefore means that the graph displayed by this equation is hyperbolic. Now that we know the type of graph, we're going to find the angle of rotation. So since A is not equal to C, we use tangent 2 theta equals B over A minus C. Now, from the general form, we know that B equals 5, A equals 8, and C equals -4. So as you can see here, tangent of 2 theta equals 5 over 8 minus -4, which simplifies down to tangent of 2 theta equals 5 over 12. Now, here you have to use the arctangent function on your calculator. You have to use your calculator on this because this is not a whole number. So once you apply the arctangent function to both sides, you get the equation 2 theta equals approximately 22.620 degrees. And then, of course, you can divide both of those by 2, so you get theta as 11.310 degrees. And that is your angle of rotation. Okay, so now we're going to graph this equation on a graphing calculator. Now, you may be wondering, well, there are 2 squared variables here. How in the world am I going to graph it on a graphing calculator? You have to set it equal to y. Well, here's how. So you may remember back in, your earlier algebra days, about quadratic form, which is ay squared plus by plus c equals 0. Well, you use that form here in order to solve for y using the quadratic formula. So in order to put, this equation into quadratic form, you have to group the variable according to y. So as you can see here, it is -4 y squared plus 5x y plus 8x squared plus 2. A in this case would be -4, b would be 5x, and c would be 8x squared plus 2. Now, then you can use the quadratic formula using this quadratic form to find out what y is. So, y equals -b plus or minus the square root of b squared minus 4ac all over 2a. And now you just plug in your a, b, and c accordingly. So you'd get y equals -5x plus or minus the square root of 5x squared minus 4 times -4 times 8x squared plus 2 all over 2 times -4. Okay, so here we are on our graphing calculator. So first let's hit y equals, and now let's enter the equation. So let's go to numerator denominator, -5x plus the square root of 5x squared minus 4 times -4 times 8x squared plus 2 all over 2 times -4. But you may notice that in your quadratic equation you have that plus or minus. So you also have to enter the same version of the equation but with that minus before the square root sign. So again, -5x minus the square root of 5x squared minus 4 times -4 times 8x squared plus 2 all over 2 times -4. And then you can hit graph and drawing. And there you go. That fits our prediction that it is a hyperbola and that is rotated 11.31 degrees about the origin. Thank you for watching this video. Please leave a like and subscribe to my channel for more content like this that may or may not ever be posted. Now, this video may have been a little long, but the amount of knowledge in mathematics that you have gained as a result of the extra length far surpasses any time that you may have spent. Thank you.